Hi guys, this is our last lecture of this open course series. I hope you enjoy this video series and also we can help you in your work and study. So today's topic is about parallel operation of IGBT and IC. So I hope you will also enjoy this last video. Let's start.
Hello guys, welcome back to our open course. This lecture is the last lecture of this open course series. The content today is about the double pulse test for parallel operation. Also, I will introduce how to conduct the short circuit test. We have today 3 chapters: influence factors of IGBT in parallel current sharing, the short circuit test of 6 modules in parallel, and then double pulse test procedure of 6 in parallel. In this slide, we can see this is a 3D view of a power stack of 4 modules in parallel operation. The first question here is that why we need parallel operation. The reason is quite simple, as only single IGBT cannot fulfill our power requirement. Therefore, we must utilize parallel operation to expand our output capability. However, then there is some challenges. For example, while we use 450 ampere module, then totally 900 ampere is required by 2 modules in parallel. 4 modules should be 1800 ampere. It looks quite good, but the problem is that how can we promise the current sharing between the parallel modules and ensure the reliability of the complete system? There are several factors can influence the system performance. We can go to this slide. I listed several important factors here. The first one is the symmetry of our DC side converter circuit. If we go back to last slide, we can see that each module has own converter circuit here, which is a good design. The second point is that the AC side of the module, we must ensure the symmetry of the output here, which means the loop must be as short as possible and consider the EMI from the external environment. From this figure here, we can find this copper here when we design this AC bar. These 2 sides are symmetric, which can improve the current sharing performance. The third point is that we must consider the heat sink design to keep that all modules are in the same heat dissipation conditions. Thermal simulation is critical here. The next point is the characteristics of the using module, especially for a silicon carbide module, because same part number module but from different batch can have different electrical characteristics. I will explain this with more details in coming part of this lecture. The last factor is our GDU. So you can see the drive technologies. As we know, GDU controls the switching behavior of the module. Therefore, it is crucial that the GDU can promise a synchronized turn on and off. And because the AC side of the parallel modules are connected, you can imagine that the emitter of the module are connected. So we can draw it like this. There is one half bridge. I draw one half bridge here. Very simply, there is another one. I just draw half of them. Okay. And the emitter is connected. So here is gate, and we give signal from here. Okay. Then there can be voltage damping on the gate while the emitter voltage is different. So you can imagine this VGE voltage is then different for the parallel module due to the stray inductance on the loop, for example here and here, which is quite significant for SiC module. Therefore, GDU must have ability to suppress this kind of damping. Here I just provide a general view what can happen here. If you have interesting, we can make a video to explain this with more details. It's quite complex and you need to improve your circuit to suppress this kind of voltage difference. Also, the current will be much higher in parallel operation case by using SiC. Such high current in like 1 microsecond can lead to strong EMI. How to protect the modules under short circuit condition is also challenging. So today we want to go deeper into how to design the power stack and the GDU for parallel operation. It is quite complex and a lot of details must be considered. I just introduce you to how to conduct the double pulse test and short circuit test first. We can go to this slide today. I want to start from the short circuit test first. The basic steps, test steps, platform, and waveform are similar. I hope you still remember the content in last lecture. I listed the steps here again, so we need to firstly make the short circuit manually, then check the signal connection, and then in third steps you need to have the low voltage pre-testing. After that you can have high voltage test, record the waveform, turn off the high power first, then record the data, read the waveform, and then you need to take for at least 5 minutes pause for the next test. So this is the same test steps. In this slide you can see this test platform. We have 6 modules in parallel. In the normal case we will short all of parallel modules during the test, but from theory it's possible that only one module is shorted. However, there can be other problems. I don't explain here too much because it is quite complex. If you want to know, we can make a short lecture to explain this situation. Okay, then let us go to next slide. I prepared the example result here because now the current is 6 times higher than nominal short circuit test. Therefore, we must focus on the isolation problem and check the protection function first, like I said in last lecture. So we can have a look. The waveform is quite similar compared to only single module short circuit test. The only difference is now you have 6 waveform of the current. Okay, this is all content today. In the second part, I will introduce the double pulse test of parallel operation. See you again. Bye.